Hello children, let's come back to our maths class. In the previous class we were dealing with exercise 7.2, yes, and we have completed with sum number 13, and today we are going to continue with sum number 14. So get ready with your classworks, write down your classworks, write down your classwork, write down today's date and copy down question number 14 from exercise 7.2. So we are going to continue from exercise 7.2, question number 14. Here are the question. If A is equal to half alpha 0 1 upon 2, prove that summation k from 1 to n determinant of a raised to k is equal to 1 upon 3 into 1 minus 1 upon 4 raised to n. So they have asked you to prove. So we are just going to prove it. So write down the question properly. So I'll write down here what is given and what to prove. Given A is equal to, so we know the matrix over here. So A is half, alpha, 0, half. Given A is equal to half, alpha, 0, half. And now what you have to prove over here? You have to prove that summation k from 1 to n determinant of a raised to k is equal to 1 upon 3, 1 minus 1 upon 4 raised to n. We have to prove that summation k from 1 to n determinant of a raised to k is equal to 1 upon 3, 1 minus 1 upon 4 raised to n. This is what is the proof part. Have you taken the given part and the two proof parts? Okay, let's start with the sum. Before we go to the proof part, we'll just try to find out some of the values and then I'll take the LHS and then I'll try to get the answer for RHS. Okay children? So I'll take the given part once again. So A is equal to half, alpha, 0, half. Okay, so this is the matrix that is given to us. I've just copied the matrix as it is. Now I'm going to find out determinant of A. I'll find out determinant of A over here. Okay, we'll find determinant of A. So this is determinant of A. Okay, they have just given me this in word form and this is the symbol form. So determinant A is just cross multiply this. So half into half. It's 1 by 4 this here. Minus 0 into alpha. What is 0 into alpha? 0. So what is the answer for determinant of A? It's 1 by 4. So I'll just write down here one more step. I'll write down here determinant of A is equal to 1 by, because here they have just given a word form, okay, determinant DET, so I'll just use here DET. So determinant of A is equal to 1 by 4. I can write down this as 1 upon 2 square. How can you write 4 as 1 upon 2 square? So just complete the step. We have just done one part, because here K is from 1 to n, okay children? So that means I have found determinant of A. So one work is done. So now I have to find out two more terms. I'll find out for determinant of A square and also I'll find out determinant of A cube and then we continue our sums. So here are the steps. So I have taken the matrix A. I have found the determinant of A as 1 upon 4 and have just written it as 1 upon 2 square. Okay. Now coming to the next thing. Now I am going to take A square. I am going to find out A square because I have to find out determinant of A square. See here, if I put here 1, I get determinant of A raised to 1. This and this is same. If I take A as 2, I get determinant of A square. If I take K as 3, I get determinant of A cube. So on. So I just want to find out determinant of A square and also I want to find out determinant of A cube. So we have to find out A square and A cube first and then only we can find out determinant part. See here now, I am going to find out A square. How to find out A square? This is A into A. Do not square this. That is wrong. You have to take A again A. So you have to multiply A with A. So this is half alpha 0 half alpha 0 half. I have taken the matrix because I want the answer for A square. It is A into A. So half alpha 0 half into half alpha 0 half. Okay, done? Now what we are going to do is we are just going to multiply this. See how to multiply the matrix. Already you will have done in your 10th standard, and the class also have taught you how to do it. See here, you have to just take row wise and here column wise. So this is how you have to draw the arrow. So first row, first column. So what is the answer here? See the answer here? Half into half. See here, half into half. It is half into half I put. Then plus alpha into 0. I will just write on the step for you. First step, alpha into 0. So I have completed the first row at the first column. Half into half plus alpha into 0. Coming to the next line. So half, that is the first row and the second column I am taking. So half into alpha, give some space because this is the first element. Now I am going to talk about the next element. This is half into alpha plus alpha into half. See the steps carefully, children. First row and second column. So half into alpha plus alpha into half. Okay. Now next line. 0 into half. I will do this step for you. For the next matrix onwards, we will try to do the answers directly. So 0 into half plus half into 0. Clear? 0 into half plus half into 0. Now, second row and second column. So 0 into alpha plus half into half. This is what I get. So half into half plus alpha into 0, half into alpha plus alpha into half, 0 into half plus half into 0, 0 into alpha, half into half into half. Let's try to simplify this further. This is 1 upon 4 plus alpha into 0 is 0. So don't need to worry about that term. Now here this is half alpha plus alpha into half. So half alpha plus half alpha. What is half of alpha plus half of alpha? 1 by 2 plus 1 by 2, it's 1. So the answer is, see actually what you get here. This is 2 alpha upon 2. So the answer is alpha. So I get here alpha. So this answer is 1 by 4. This answer is alpha. Here this is 0 plus 0. So overall answer is 0. This is 1 upon 4. 0 into alpha gives you 0. 1 upon 2 into 1 upon 2 is equal to 1 upon 4. So we have found the answer for A square, which is 1 upon 4 alpha 0 1 upon 4. Okay, so now we have completed A square. See, once we know the value for matrix A, we have found the determinant of it. So I know the value for A square, so now I have to find out determinant of A square. So just complete the step. Have you completed the matrix? Okay, now just see what to do for determinant of a square. Determinant of a square, we just cross multiply this. 1 upon 4 into 1 upon 4. That's 1 upon 4 into 1 upon 4. 0 into alpha will give you 0, so nothing will come here. So this is equal to 1 upon 16. We have written 1 upon 4 as 2 square. So how can you write 16 in the form of 2 power? It will be 2 into 2 into 2 into 2. So we get the answer as 1 upon 2 raised to 4. So we have found the value for determinant of a square also. That is 1 upon 2 raised to 4. So determinant of a is known to us and determinant of a square is known to us. So we have to just find out one more matrix and then we will continue with the proof part. So I have to find out now a cube. I'll just take the values from there. I have to find out a cube. So a cube will be written as a square into a. Okay, so a square we wrote as a into a. Similarly, a cube you have written as a square into a. So what is a square value? It is 1 upon 4 alpha 0 1 upon 4. And what is the value for a? It's 1 upon 2 alpha 0 1 upon 2. So we have to multiply these two matrices. Just substitute the value. So a cube is equal to a square into a. I have substituted the value for a square and I have substituted the value for a. Okay, have you taken down? Okay, let's go for the matrix multiplication. Let's see how to multiply this matrix. So what we have to do is the first row and the first column. See, 1 by 4 into 1 by 2. What is 1 by 4 into 1 by 2? It's 1 by 8. 1 by 4 into 1 by 2. 1 by 8. Alpha into 0. Alpha into 0? 0. So that's all. So what is the first answer? 1 upon 8. Coming to the next element now. The first row and the second column. So 1 upon 4 into alpha. 1 upon 4 into alpha plus alpha into 1 upon 2. Alpha into 1 upon 2. Here. Now 0 into 1 upon 2, 0. Plus 1 upon 4 into 0, 0. So I get here the complete answer as 0. Now here, 0 into alpha, 0. 1 upon 4 into 1 upon 2. Again I get the answer as 1 upon 8. I just explain you the step once again. The first row and the first column. So 1 upon 4 into 1 upon 2. 1 upon 2. So this and this. Plus alpha into 0. That is 0. So I have just taken the first multiple. That is 1 upon 4 into 1 upon 2. The first row and the second column. 1 upon 4 into alpha plus alpha into 1 upon 2. Then 0. 0 into half, 0. 0. 1 upon 4 into 0, 0. Next, 0 into alpha, 0. 1 upon 4 into 1 upon 2, 1 upon 8. So, first row, first column, first row, second column, second row, first column, second row, second column. So, I just write the simplified formula. This is 1 by 8. This is alpha upon 4 plus alpha upon 2. and this is 0 here, and this is 1 by 8. No need to simplify this, we will just keep this as it is because we are not worried about AQ, we are just talking about determinant of AQ. So now you write down here, determinant of AQ is equal to, multiply, cross multiply. So 1 upon 8 into 1 upon 8, 1 upon 64, and this 0 multiplied by 8 number gives you 0. So we get the answer as 1 upon 8 into 1 upon 8, which is equal to 1 upon 64. See here. So 2 into 2 into 2 into 2, 4, 8, 16. Yes. Into 2 into 2, 32 into 2, 64. So 2 raised to 6. 1 upon 2 raised to 6. So we have found the determinant of A cube also, that is 1 upon 2 raised to 6. Take down the steps. So I know the matrix A. So using matrix A, we have found the determinant of A. Then I found A square by multiplying A into A. I got the determinant of A square. Then I found A cube. By A square into A, I took the determinant of A cube. Copy down the steps. Have you taken all the steps? Now, let's come to the LHS part. I am going to take the LHS part now. So, what is LHS? LHS is summation k from 1 to n, determinant of a raised to k. This is your LHS, and we have to show that this answer is equal to 1 upon 3. 1 minus 1 upon 4 raised to n. This is what we have to show. So LHS summation k from 1 to n, determinant of a raised to k. Okay, so I am just going to expand now. I am just going to simplify the LHS part and see how to get the answer. So this is equal to, I am going to remove the summation. So I get here determinant of a. If I take 1, I get a raised to 1, that is a. If I take 2, I get determinant of a square plus determinant of a cube, and it goes up to determinant of a raised to n. So I get determinant of a plus determinant of a square plus determinant of a cube plus determinant of a raised to n. Okay children, so now I know the value for determinant of a square, determinant of a cube. So I am just going to substitute the values. So I get here this is equal to, what was the value for determinant of a? It was 1 upon 2 square, yes, because we got answer as 1 upon 4. So we have taken as 1 upon 2 square. Then we know the value for a square, it was 1 upon 2 raised to 4. And this is 1 upon 2 raised to 6. And I don't know the remaining values, so just put their dot. We can just go on finding, but enough. Just first 3 values are enough. So we get the value as 1 upon 2 square plus 1 upon 2 raised to 4 plus 1 upon 2 raised to 6 plus dot. Okay, now what are we going to do here? See. Now this is in the form of GP. How to find out for GP? For GP we have to just see the common ratios. If the common ratios are same, we can say the given sequence is in GP. And if we get a common difference, you can say that the given sequence or the series are in arithmetic progression. So we have seen about arithmetic progression and geometric progression in our 10th standard also, and also we have seen in our 5th unit. Yes, student? So there we have seen about AP and GP. So now let's see over here. I'll just check it out whether it's a GP and tell how to check it out. See now here, T1 is, this is just for your reference, you're just going to take this in your left hand side. You can use pencil and you can just check it out whether it's a GP. For GP, what you have to take it out? You have to just take it out whether the ratios are same. The T1, I take the first term, this is 1 upon 4 I think, okay, 2 square, that is 1 upon 4. What is T2 now? It's 1 upon 16. I'll take for T3 also. What is the third term? It is 64, 1 upon 64. Okay, I'll find out T2 upon T1 first. Okay, what is T2 upon T1? 1 upon 16 upon 1 upon 4. Okay, very easy. You know, I have just substituted the value for T2 and I have just put the value for T1. So this is fraction upon a fraction. So write the numerator part as it is. And you have to take the reciprocal of the denominator. So this becomes 4 upon 1. So what I get? 4 ones are 4 fours are. So this is 1 upon 4. Clear? Now I'll check it out for one more ratio because I have to check it out whether the ratios are same. So I have found for T2 upon T1. Now I will find out for T3 upon T2. So what is T3 upon T2? T3 is 1 upon 64. And what is T2? 1 upon 16. So same procedure. Take the numerator part as it is. And you have to take the reciprocal of the denominator, that is 16 upon 1. 16 ones are, 16 fours are. So I get the same answer, 1 by 4c. So we have the common ratio, we have same ratio. So we can say the given sequence, okay, here it is addition, okay, the sum of the sequence. So it is GP. If you have the common ratio, you have to say the given sequence is in G. You have to show this as your rough work. Show the calculation. No one is going to skip this calculation. You have to show this calculation. You should know how you have to check it out for GP. Okay, have you written? Okay, now let's see how to go further. So now we are just going to use one formula over here. I'm going to write down the formula for S because I want the answer is, I'll take the formula, sum of the series. I write down that Sn is equal to 1 minus, I'll write first A here, A into 1 minus R raised to N upon 1 minus R. This is the formula for GP. If you are going to find out the sum of a GP, this is the formula we have to use. Sn is equal to A 1 minus R raised to N upon 1 minus R. These are all the formulas were done in our 10th standard. If you have your 10th standard textbook, you can refer your 10th textbook for the formulas. Sn is equal to A into 1 minus R raised to N upon 1 minus R. Okay, done? So we are just going to substitute the value here. I know the first term. What is the first term? 1 upon 2 square. So just write down this is 1 upon 4. I have taken it as 1 upon 4. And 1 minus R. What is our R common ratio? It's 1 upon 4. So just put here 1 upon 4. The whole raised to N upon 1 minus 1 upon 4. Now just done the substitution work. So here A is 1 upon 4. I just mention here A is equal to 1 upon 4 and R is equal to 1 upon 4. R is here. The common ratio is R. So I just substituted the value. 1 upon 4, 1 minus 1 upon 4. Use a bracket because we have a power here. So raised to N upon 1 minus 1 upon 4. I'm just going to simplify this. I just do the calculations over here. So 1 upon 4 I will keep it as it is. And this will be now 1 minus, anything raised to 1 is going to give you 1 and this will become 4 raised to n. So I get 1 minus 1 upon 4 raised to n. See, we have come to this part. Upon 4 into 1, 4 minus 1, 3 upon 4. So I get 1 upon 4 into 1 minus 1 upon 4 raised to n upon 3 upon 4. So now what happens here? The 4 and the 4 gets cancelled and we have 1 upon 3, 1 minus 1 upon 4 raised to n. So this is our RHS. You can say therefore LHS is equal to RHS, hence proved. I get LHS is equal to RHS and hence proved. Just remember the formulas. If you know the formula, it's very easy to substitute. The sum may look lengthier and different, but when you just understand the steps, it's very easy. Okay. I hope you have completed this sum. So this was our sum number 14. Now let's go for sum number 15. Take down question number 15. In 15, the first part I'll be doing over here, and the second part from question number 15 will be your homework. I'll just mark the homework part here. 15th question, subpart 2. The second subpart is your homework, and now get on the first subpart. Without expanding, evaluate the following determinants. The first subpart, it is 2, 3, 4, 5, 6, 8, 6x, 9x, 12x. 2, 3, 4, 5, 6, 8, 6x, 9x, 12x. Just here the determinants. Okay, so we have 2, 3, 4, 5, 6, 8, 6x, 9x and 12x. They say that do not expand. Do not expand means no need to expand it again. Without expanding, we have to find out the answer. So now we see here 6x, 9x, 12x. So these are the multiples of 3. Okay. So what I am going to do is I am going to take 3x common from the third row. So what is going to be taken common out? 3x is going to be taken out from the third row. So I will take 3x outside the determinant. So what is left now? 2, 3, 4. I am not going to do any changes in the first row, in the second row. Only I am going to take 3x common from the third row. So this is 5, 6, 8. Now this is 3x I have taken common. So this becomes 2. 3 2s are, yes. This is 3 3s are 9, so 3 and already x is taken outside. 3 4s are 12 and x is taken outside. So after taking out 3x common, I get the third row as 2, 3, 4. I get 3x into determinant of 2, 3, 4, 5, 6, 8, 2, 3, 4. Okay, now just see here the first row and the third row are identical. Yes or no? This first row and the third row are identical. So you have to say here, since row 1 is identical to row 3, if any two rows or if any two columns are identical, then we know that the determinant value is 0. Already we have used this property in our sums. So this is 3x into 0, which is equal to 0. So I have found the answer for the determinant. So what is the value for this determinant? The value for this determinant is 0. I have just got that two rows are identical. So using the property of determinant, I have found the answer as 0. So anything multiplied by 0 will give you 0. So we have found the first subpart. And I have told you to complete the second subpart as your homework. It's very easy. Again, the second subpart you can use some of the changes and you can get your answers. Okay, this was very easy sum. So just understand. They have just given you the sum so that you people can understand the properties. Okay, now coming to the next sum. Take down question number 16. So 15 is done. Now go for question number 16. Take another question. If A is a square matrix and determinant of A is 2, find the value of determinant of A transpose. If A is a square matrix and determinant of A is 2, find the value of determinant of A transpose. Okay, again here we are going to use some of the properties of determinant. Just mention the properties over here. Before going to the sum, we will use some of the properties. You can just write down the left side of your paper. Properties of determinant that I am going to use over here. If it is determinant of AB, okay, if you have determinant of AB, you can write down it as determinant of A, determinant of B. This is one property. Okay. So what is determinant of AB? Determinant of AB is determinant of A, determinant of B. And we can use one more property. It is determinant of A is equal to determinant of A transpose. We have these two properties. So I am just going to use these two properties in our sum number 16. So determinant of AB is determinant of A, determinant of B, and determinant of A is equal to determinant of A transpose. Clear, children? So now what are we going to do? We are just going to use it. So now what is the question here? They are saying that determinant of A is 2 and determinant of A transpose we have to find out. So write down. Given determinant of A is 2 and you have to find out determinant of A transpose. We have to find determinant of A transpose and just take down what is to be found and write down here A transpose is equal to. See here, if it is determinant of AB, it is determinant of A, determinant of B. If it is determinant of A transpose, it will be determinant of A, determinant of A transpose. Very easy. See, determinant of AB instead of B, what you have here? A transpose. Now what is the value for A transpose? It is A. So determinant of A is equal to determinant of A transpose. So in place of determinant of A transpose, you can put determinant of A. So this is equal to determinant of A, determinant of A. I get determinant of A, determinant of A. So I know the value for determinant of A, determinant of A is, what is determinant of A? It is 2. So just substitute the value 2 into 2 which is equal to 4. So we have found the answer for determinant of A transpose is equal to 4. Highlight your answer. I found the answer, it's 4. Okay, so just mark down some more homework questions. So we have completed sum number 16. Your homework will be sum number 17 and 18. So homework for today is question number 15, second subpart, question number 17 and question number 18. And we have some more sums, 3 more sums are left over here. And we will be continuing with the remaining sums in the next class. And do not forget to complete your homework on time. Complete all your works properly on time.